Hello everyone, welcome back again. Today we are going to walk through a typical network architecture on Google Cloud Platform or GCP. This diagram which you're seeing right now in the screen, it looks complex though. It is essentially a blueprint for building highly available, scalable and secure applications. At its core, GCP leverages Google's immense global network. This means your application can be designed to serve users anywhere in the world efficiently. Our diagram illustrates how we bring together different components to achieve this, focusing particularly on how traffic is intelligently managed and distributed. So let's start from the top where users interact with our application. The first key components they encounter and the heart of our front door in GCP is the global external load balancer. This is a layer 7 load balancer. Why layer 7? Because it understands the application level protocols like HTTP and HTTPS. This means it can inspect the URL, headers, and even cookies to make smart routing decisions. For example, it can send requests for images to one of the servers and API requests to another. Crucially, this load balancer is global, meaning it can direct traffic to the closest healthy backend instance anywhere in the world, ensuring low latency for your users. Before traffic even hits the load balancer, it passes through Cloud Armor. Think of Cloud Armor as our bouncer and security guard. It provides DDoS protection and acts as a web application firewall, filtering out malicious traffic and protecting our applications from common web vulnerabilities at the very edge of Google's network. So once traffic passes the layer 7 load balancer, it intelligently routed to a specific region like a region A or region B shown here. Within each region, we typically have our web servers or front-end applications often running within managed instance groups. I know we have used a couple of jargons here. Don't worry about it. We're going to explain each and every one of it. So these managed instance groups automatically scale up or down based on demand, ensuring your application can handle fluctuating traffic loads. So now for traffic within your own private network, particularly from our web servers to our backend services, we introduce the internal pass-through network load balancer. This is our layer 3 load balancer. Unlike the layer 7 load balancer, this network load balancer operates at the IP and port level. It is incredibly efficient for distributing TCP/UDP traffic to backend VMs that host our core application logic or even database clusters. It does not inspect application content, but simply forwards traffic, unlike layer 7 load balancer. So it is ideal for high performance internal communication. Below these backend instances, we see our private subnet and potentially our databases, ensuring that these critical components are never directly exposed to the internet. All these components, your virtual machine, load balancers, and databases reside within your VPC network. The VPC is your isolated network. Remember, we talked about that in our previous video, that VPC is an isolated network within the GCP, encompassing all your resources across regions. Cloud routers handle the routing within and between regions, ensuring seamless communication. Finally, services like Cloud DNS, which provides reliable resolution and entire setup benefits from GCP's underlying cloud global backbone network, which is Google's private high-speed fiber network. So in essence, this architecture allows us to build applications that are not only powerful and scalable, but also incredibly resilient and secure by intelligently distributing traffic and protecting it at every layer. So in our upcoming videos, we're going to dive deep further on making a decision and understanding when to choose which load balancer. So in this video, we understood what are different kind of load balancers, And in next video, we'll bring a use case scenario and understand more.